Alright, hey guys, so now we're going to take our standard form stuff and apply it to some real life problems. Alright, so this is what your page looks like, and I separated it out so I got a little more room. So demand function. The consumer demand for a given product depends on its price. So basically if something costs more, less people are going to want it, so the demand will go down. So you have kind of a looking like this graph, right? The demand equation for a Sicard wristwatch is 0.25x plus y equals 50. So that just relates supply and demand, where x is the quantity demanded, so x is demand per week, and y is the price in dollars, so y is the price. Alright, so essentially if y is the price, we have a picture that looks like this. Y is our price, demand, or the number demanded, is our x. So higher price, less people, smaller x, less demand. Smaller price, bigger demand, right? Higher x. What is the highest price theoretically anybody would pay for the watch? So the highest price is right here, right before 0 people buy it. Alright, so that's our y-intercept. So for price, since that's the y, it's our y-intercept. So how do we find our y-intercept? We know that x is 0 at our y-intercept, so then we just plug that into the equation. So we have 0.25 times 0 equals, or plus y equals 50, so y equals 50. So hypothetically, $50 is the highest price anybody would pay, according to our equation. So what is the demand theoretically when the watch is free? So if the watch is free, that's when our price is 0. So a 0 price is our x-intercept. That's here. So if our y is 0, we have 0.25x plus 0 equals 50. So we have 0.25x equals 50. Divide both sides by 0.25. And we get x equals 200. So hypothetically, if the price was 0, then 200 people would want the watch, or the demand would be for 200 watches. Alright. So here's another little more interesting one. Hiking. The graph relates the temperature to altitude. Alright, so we're relating temperature to altitude. So as you climb a mountain, the air gets thinner and the temperature drops, actually just based on the air and your altitude. So its temperature is in degrees Fahrenheit and altitude is in thousands of feet. So find the x and y intercepts. The y-intercept is easy. That's given to us. So the y-intercept is 0, 59. Alright, so when x is 0, the y is 59. That's where we hit the y-axis. So for the x-intercept, we would have, it's right about here. Alright, now that looks like it's about a quarter of the way between this, so 16, this would be 18, halfway would be 17, halfway between 16 and 17 is 16,500. So I'm saying that the x-intercept is approximately, it's hard to tell from this graph, it's about 16,500. Alright, so see, this is in thousands of feet. That's why I wrote 16,500 instead of just 16.5. Alright, so there we go. So in the, and interpret each in the context of the problem. Sorry, so this is at sea level, it's 59 degrees Fahrenheit. And then at 16,500 feet elevation, so you're up a big mountain, the temperature is 0 degrees, or freezing. So what is the slope of a line? What does it mean in the context of our problem? Alright, so that's easy. We just got to do our slope formula with 2 points. We have 2 points here. Here's our x1, here's our y1, here's our x2, here's our y2. So we're just going to use the formula, I don't know, change in y over change in x, which is y2 minus y1 over x2 minus x1. Remember, the little triangle just means change in. So then this is going to be 0 minus 59. This is going to be 16,500 minus 0. So that's easy. That gives us negative 59 over 16,500, which is approximately 0.0036. Amazing, I did that in my head that quick. So what does that mean in the context of the problem? All right, so we have change in y over change in x. Y is our temperature, x is our altitude. So change in temperature over change in altitude. So what that means is, and this is negative, my bad. So that means that we go down 0.0036 degrees for every foot, because this is measured in feet. For every foot, we go up in elevation. So if you go up 1 foot, it's not even close to a degree. If you went up 100 feet, it would be 0.36 degrees. Not a big deal. But when you're climbing 16,000 feet, obviously, that's a bigger deal. So here is your you try problem. All right, give it your best shot. You should be able to do that easily based on the things we did in these first two problems. And I'll see you next class. And don't fail like this guy. Or this guy. Whoops.